Greetings, curious humans of Earth. I am Professor Zainstein, traveling scholar from the Andromeda Quadrant. I've crossed light years, dodged black holes, and slightly missed my exit at Saturn, all to ask one very important question. How did your universe begin? Long before planets, before stars, before even time knew what time was. Boom! The universe exploded into existence in an event humans call the Big Bang. But here's the twist. It wasn't an explosion in space. It was an explosion of space itself. In today's lesson, I'll break it down the human way. No scary math, no galaxy-sized headaches, just cosmic chaos made simple. So strap on your gravity boots, activate your curiosity circuits, and prepare your brain cells, because class is in session and the universe is about to begin. Welcome to Space Guide for Humans. From where I come from, humans are known as the young species because your world is only just beginning to understand the true age of the universe. On my planet, we study the beginning of everything the way Earth studies ancient history, not as a story, but as a major event that shaped all reality. What you call the Big Bang is not just the start of stars or planets, it is the start of space itself, the start of time, and the start of every tiny building block that later became galaxies, suns, worlds, and living beings. When I say this to your kind, I notice humans often imagine the Big Bang like a bomb going off somewhere in the universe, as if there was already a dark, empty room called space and something exploded inside it. But from our scientific view, that is not what happened. There was no room yet. There was no outside. There was no before in the normal way you think about it, because time had not begun behaving like time yet. The Big Bang was the moment when the universe began expanding from a state that was unbelievably hot and dense, so dense that everything that would someday become planets, people, and even the light in your eyes was packed into an area far smaller than anything you could point to on Earth. Imagine you have the most powerful pressure possible, pushing everything into the tiniest space imaginable, like the whole universe squeezed into something smaller than a single dot you could draw. That early universe was not full of stars or atoms. It was more like a storm of pure energy. It was so hot that matter could not stay matter for long because everything kept smashing together too violently. If you could have watched it, it would have been impossible to see anything clearly because the universe was like a blinding ocean of heat and light. Then the universe began to expand. Expansion does not mean it grew into something else. It means the space between everything began stretching, like a rubber sheet being pulled wider and wider. But unlike a rubber sheet, there was no edge you could reach. The whole universe was all there was, and it began increasing in size everywhere at once. That is why we say it wasn't an explosion in space, but rather space being created and stretching outward, carrying all the energy and future matter with it. As the universe expanded, it also cooled, because spreading out makes things less hot. This cooling is one of the most important ideas, and it helps explain why the universe changed from a chaotic energy storm into something that could eventually create galaxies. After some time, the energy in the universe settled down enough to form tiny particles. These particles are like the first ingredients of everything, but they were not the kinds of particles you recognize from everyday Earth life. They were strange and unstable at first, zipping around at incredible speeds. Over time, as the universe cooled more, these particles were able to stick around long enough to interact and form the early pieces of matter. Eventually, they formed the most important particles for building atoms, things like protons and neutrons. Later, electrons could exist as well. When those pieces finally started working together, it became possible for the universe to form simple atoms, mostly hydrogen and helium. Hydrogen is the lightest element and one of the most common, and helium is also light and common. In alien schools, we teach students that the early universe was like a soup made mostly of these two ingredients. This soup didn't taste like anything, of course. It wasn't like food, but it was thick with gas drifting through newly formed space. For a long time after that, the universe was dark, not because it was empty, but because stars had not formed yet. The universe had the ingredients for light, but not the machines that make powerful light. Stars are like gigantic engines that turn gas into heat and brightness. So in the early universe, everything was calm and dim in a way humans often find hard to imagine. Yet gravity was already working. Gravity is like the universe's habit of pulling matter together. Wherever gas was slightly thicker than its surroundings, gravity pulled more gas into that spot, making it thicker and thicker. Over millions of years, these growing clouds of gas collapsed into the first stars. When the first stars ignited, they became bright beacons in the darkness, and the universe began filling with light. Those first stars were huge and powerful, and many of them lived fast and died young. When they died, they often exploded in massive events called supernovas, spreading new materials into space. This matters because early stars created heavier elements inside them, elements like oxygen, carbon, and iron, and these heavier elements are necessary for rocky planets and living beings. From an alien point of view, those first exploding stars were like cosmic artists, painting the universe with new colors and new building blocks. Eventually, over billions of years, clouds of gas and dust, now filled with heavier elements, formed galaxies, and inside galaxies, new stars formed, and around those stars, planets formed. Your Earth is one of those planets. You are made of materials that were once inside stars, which is why some alien teachers say humans and aliens are children of starlight. But even more interesting is the fact that the Big Bang was not a single moment that ended. It was the beginning of a long process that is still happening. The universe is still expanding even now. Galaxies are still moving away from each other, not because they are traveling in space like ships, but because the space between them is stretching. If you lived long enough and could watch far enough, you would see the universe slowly changing shape over time, like a gigantic web being pulled wider and wider. But the Big Bang was the start of that stretching, the start of everything growing from simple beginnings into the complex universe you see today. From an old alien's perspective, the Big Bang is both simple and shocking. Everything began from one state, and over time, that state changed into the entire universe full of stars, planets, and life. What amazes us is not just the power of the beginning, but the results, that from pure energy came particles, from particles came atoms, from atoms came stars, and from stars came worlds. And on some of those worlds, like Earth, matter became alive and began asking questions about where it came from. When we look at humans, we don't just see a species on a planet. We see a rare event, the universe becoming aware of itself. And it all started with that first expansion, the moment you call the Big Bang.
All right, my brilliant Earth students, that brings us to the end of today's cosmic lesson. You've just traveled through one of the greatest mysteries ever discovered, the Big Bang Theory. The moment your entire universe began its long journey from nothing you can imagine to everything you've ever known. And I want you to really sit with that for a second. Because the Big Bang wasn't just some loud explosion floating in space like a giant firework. No, no, no. The Big Bang was the moment space itself was born. It was the moment time started ticking. It was the beginning of all the energy, all the matter, all the laws of physics, and every future galaxy, star, and planet that would ever exist. So when humans ask, what happened before the Big Bang? That question is tricky, because before only makes sense when time exists, and time didn't behave like time yet. From an alien professor's perspective, that's not just science, that's cosmic poetry. And here's the best part. The universe didn't just appear and stop. It's still expanding right now. Galaxies are still drifting apart, space is still stretching like an infinite cosmic ocean growing wider every second. The same event that gave birth to everything is still shaping everything. You are living inside an ongoing story that started nearly 14 billion years ago, and your life is a tiny but meaningful part of that giant timeline. So the next time you look up into the sky at night and you see stars scattered like diamonds, understand something. You are not just looking at stars, you are looking at ancient light. Light that's been traveling for millions, even billions of years just to reach your eyes. And that means you're basically looking into the past, which also means your eyes are time machines. Now tell me, Earth student, how many species can say that? So if you enjoyed this lesson, do the ancient Earth ritual. Smash that like button, subscribe to join the Zeinstein Intergalactic Academy, and drop a comment below telling me what cosmic mystery you want next. Do you want to explore black holes and what happens when time bends? Do you want to understand dark matter, the invisible thing holding galaxies together like glue? Or do you want to dive into alien civilizations and the terrifying question of whether humanity is truly alone? Either way, I'll be watching from beyond your atmosphere. Until next time, this is Professor Zeinstein signing off. Stay curious, stay fearless, and always remember, you are made of stardust, trying to understand the stars.